we're going to look at what we call number bonds. It's a way to add and subtract. It's a way to think flexibly with numbers. What we find, you'll hear a lot of people say, kids aren't good with their math facts today. What we really understand now about math is the math facts aren't as important as if kids understand how numbers are related and how they can go together. And I'm going to show you that through what we call number bonds. Right here, this is one of the challenging math facts for children. It would be one of the harder ones. It's hard for them to memorize. It's hard for them to look at and come up with the answer. But we realize that that number 8, if we think about it, if we looked at it visually, it would look like this. And what we hope is kids see pictures, models for numbers. So if they're seeing the 8, they're seeing this. And if we're seeing this, we're saying, man, wouldn't it be awesome if I had something that could just go in there and fill up that 8 into a 10? Because anytime I add a 10, it's so much simpler. But in actuality, we do have something that has 2 to fill up that 10 frame. Right here, we have a 5 and a 2. The 5 and a 2 are what we call a number bond for that 7. And so what we can do is we can use that 2 from our 7 and we can give it over here to the 8 and it can fill it up. So now we're not dealing with an 8 anymore, we're dealing with the number 10. And so we've used this 2, but we still have that 5. So if we put them together, we have 15. A much simpler fact for a child to add or calculate inside their head is 10 plus 5. And all I did was I broke apart the 7. And I'll just show you one more time so that you can kind of see how we do that. You might see something like this. And your teacher would expect your child to see it like this. And what we might do is see the kids do something like this. Because they've used the 2, so they're just still adding the 5. And so they get the answer 15. You may hear this called the break apart strategy, but in actuality it's what we call number bonds, because a 2 and a 5 are bonding together to make that 7. And it's not the only way we can do this math fact. Let's look at another way we can do it. If we think about 8 plus 7, I realize that my 7, he really just needs a 3, and he could be a 10. And sitting here inside this 8 is a hidden 3. So if I use that hidden 3 with my 7 to get a 10, now again I'm adding 10 plus 5, which would give me 15. So I have a very simple way to get at the answer, even though I might be stuck initially. Look at it again, and this time I'm going to use what we call doubles. So 8 plus 7, and I want to use my idea of doubles. A double is a number plus the same number twice. Now I don't have another 7, I don't have another 8, but I do have another 7, really. He's hiding inside that 8, because a 7 and a 1 do make the 8. So I'm going to use the 7 and the 7, and I know my doubles. If we don't memorize anything else, let's memorize our make a 10 facts, how to make a 10, every number that go together to make a 10, and memorize our doubles. So now that I know that's 14, plus one more, I know the answer is 15. Super simple way to get at that math fact that was hard for me before. Now, you may be saying to yourself, why would I want to teach my kid this? How's this going to help them with larger numbers? Because I see this, and it's working with small numbers, but how's it going to work with larger numbers? Well, let's look. Let's look at larger numbers. Let's take 23 and 39. And if we think about 23 and 39, it's really a 20 and a 3 and a 30 and a 9. And we call this decomposing, but it's still number bonds because still the 20 and the 3 go together to make the 23. But I'm looking at it, I'm saying, well, really, 9 needs a 1. Where's a 1 hiding? There's a 1 hiding right inside this 3 because isn't really a 3, a 2, and a 1. So now I'm going to use the 1 and the 9, and I'm going to get a 10. And now that I've used the 1 and the 9 to make a 10, now all I'm adding is 20 and 10, which that would make a 30. And I'm going to add 30 more, which would make 60. And then I still have to add this 2 right here. So these are the only numbers I'm adding: 20, 10, 30, and a 2. And you can actually probably do that in your head and realize you get a 62. What's another way? That's not the only way. There's lots of ways when you start looking flexibly at numbers and math facts. Look at 23 and 39. And again, we're going to think of it as a 20 and a 3 and a 30 and a 9. And you may say, well, that's not different at all from what you just did. Well, hold on. So 20 and 30 would go together and make a 50. And the 3 and the 9 can go together and make a 12. Do you see an answer sitting there? I do. 62. A lot simpler for kids to go ahead and solve and figure out the answer than doing necessarily the standard algorithm, which would require regrouping. Here I'm not really having to regroup. 9 and 3 is a math fact. So I should have that kind of memorized, or I should know it, or I should think 9, 1 more makes a 10, and then 2 more would make the 12. So this helps give kids power over large computations, and it can be done even with larger numbers, and it can be done with multiplication and division. And so we'll be teaching children that as they go along, because our whole idea here is that no longer will just certain kids be good at math. We often hear, well, I wasn't good at math, so I don't really expect my kid to be that great at math because I never was. But the thing about it that we've learned is the reason kids struggle with math isn't because they're not good at it. It's because it hasn't been explained well to the kids. And so we're trying really hard to have all children understand numbers better and think more flexibly with them so that they can do better things in math and have a better foundation. So hope this helps you. This is all about number bonds.